Okay, so this lesson is about combined gas law calculations. Now, in the previous lessons, we we looked at standard temperature and pressure. So recall that standard pressure at sea level is 101.3 kilopascals or 760 torr or 760 millimeters of mercury. And your standard temperature is 0 degrees Celsius. And of course, all of our calculations, we have to convert that to Kelvin, which is 273 Kelvin. So what we have from that is STP, and some of you have noticed this in the workbook already. STP, you asked me what it stood for, and I told you I would tell you later, so here I am. It's standard temperature and pressure, and that is a constant. If you have calculations and it tells you you're working with standard temperature and pressure, or STP, then you are working with 101.3 kilopascals at 0 degrees Celsius. Now there's also standard ambient temperature and pressure, and SATP, okay, is 100 kilopascals at 25 degrees. So this is something that you have to be aware of when you're working on these questions. Is it STP or is it SATP? So ambient temperature and pressure is your 100 degrees, or sorry, your 100 kilopascals at 25 degrees, and your STP is your 101.3 kilopascals at 0 degrees. Okay. So the last lessons we were looking at Boyle's law, Gay-Lussac's law, and Charles' law, and just to recap, these are those. So what I do want you to take note of, Boyle's law, V1P1 equals V2P2, so that's at a constant temperature. Gay-Lussac's law is P1 over T1 equals P2 over T2, and that's at a constant volume. And then you have Charles' law, V1 over T1 equals V2 over T2. When you combine them all together, you get this nice combined gas law that looks like this and can be very useful. So your initial pressure and volume divided by your initial temperature is equal to your final pressure and volume divided by your final temperature. So let's just look at this example. The thing that I want you to make sure that you do is when you're doing these, you have to write down your givens, what you already know, and then what you're looking for. So for this one, Sarah's having a birthday party on a mild winter's day. The weather changes and a higher pressure, 103, cold front, minus 25 degrees, rushes into town. The original air temperature was minus 2 degrees, and the pressure was 100.8 kilopascals. What will happen to the volume of the 4.2 liter balloons that were tied to the front of the house? So with any word problem, and you know this from math, you should read it first. Once you read it, go back and highlight what's important. So with this one, we have a pressure, okay, and we have a cold front that rushes into town. It tells us the original air temperature was -2, minus 2 degrees, and the original pressure was 100.8 kilopascals. And it's asking then what will happen to the volume of the 4.2 liter balloons that were tied to the front of the house. So we are, is that volume going to change? So this is your initial volume. So the only one that we don't have and the one that we're looking for is that final volume of the balloons at the front of the house. So when you write down those givens, we had the initial pressure, we had the initial volume, we have the initial temperature. We know that this front comes in, that's negative 25 degrees with a 103 kilopascals. Don't forget to change your degrees Celsius to Kelvin for both temperatures. Okay, so now we have 5 out of the 6 variables, and we have our combined gas law formula, and we just plug that in, and we're solving for V2. So you have to be able to rearrange the formula. This is divided by T2, so we're going to bring that over. and we're going to multiply by T2, and you multiply this side by T2, which gets rid of it, or you just bring it over to the other side. What you're left with then is V2 times P2. So then if you're multiplying this, then you're going to bring that over and you're going to be dividing by P2. So what the rearranged formula looks like is exactly that. You plug in your numbers and then you just do the math. So the balloon volume decreased to 3.8 liters. I would like for you to pause it here and try this one, see if you can come up with the right answer. And once you do that, you can move on to your solution. Same idea. This one, you're looking for the final temperature, and you have to rearrange your equation. So these were your givens. This is the equation, and the solution is 95 degrees Celsius. And yes, if this is your final answer in Kelvin, you should change it back to Celsius and give the new temperature in Celsius. And that's your combined gas laws.